Hello guys. For this second example, we're going to find the theoretical probability of getting an even number or a number 3 when a die is thrown. So again, if I have a die and I throw it up, what is the probability, theoretical, because I don't have the die in my hands and I'm not conducting the experiment myself. But theoretically speaking, knowing the facts about a die, what is the probability of getting an even number or a 3 when a die is thrown? I'm going to follow the same steps I did earlier. The first thing I'm going to identify is my total. You always have to identify your total. If you have a table on your problem and you have a bunch of different outcomes, you always identify the total outcomes, which is your denominator. Very important. So the total amount of numbers or total amount of possible outcomes on the die is going to be 6 numbers, right? If you remember what a die looks like, or if you have a die at home, you know that it goes from 1 all the way to 6. So there's only 6 possible outcomes. So I'm going to identify my total. 1. The total possible outcomes is, and I can actually name them all. That would be my sample space would be 1, 2, 3, 4, 5, and 6. But I just want the amount. Okay, so that's a total of 6. 6 is the total amount of possible outcomes. Now for my second step, I'm going to identify the outcome that I want. On this problem, on the first one, I only wanted one outcome. I just wanted tail out of a total. But here I want 2 things. I want an even number or a 3. So an even number or a 3. And in math, or, very important. Or means you're going to add. Okay? So you're going to add them. Because you want that, or, again, if I tell you, give me pants or shirt, you're gonna give me only one of those items. But in math, in probability, when I ask you for the word or, you have to add. Okay, very important. So don't get confused with that word or. You have to add them. So I want the probability of something and the other one as well. So for an even number, I know that for the probability of getting an even number on a die, it's gonna be either a 2, that's 1, a 4, and a 6. Those are 3 out of 6. And remember, we always write the denominator. Again, we write probability as fractions or percentages, or even whole numbers if I can simplify it. And we simplify, very important. So this is the probability, and I'm gonna write down probability of getting an even number, and I'm gonna write this here so that I know which probability I'm referring to, because there's 2 different probabilities here. Probability of an even number is gonna be a 3 out of 6, which when I simplify that, 3, I can divide both numbers by 3. It's 1/3, right? I'm sorry, not 1/3, 1. And I'm gonna find also the probability of getting a 3. This means the probability of getting a 3. The probability of getting a 3, how many 3s are there on a die? Just 1. 1 is the only probability. 1 out of 6, which is your total. So this is 2 of them. Okay, I'm gonna keep this form here just to add it easier. Again, you can just add it in your calculator, but I'm gonna add this because the word or means I add. So my total is gonna be 3, 6 plus 1, 6, and I'm gonna keep the same denominator so that it's easier to add for step 3. The my fraction, I'm gonna simplify this fraction. 3 plus 1 is 4/6, 2/3. 2/3, and if you wanted to turn that into a percentage, you can divide in your calculator 2 by 3 and then multiply by 100. And that is approximately 66.7%. So the theoretical probability of getting an even number or a 3 is going to be 66.7%, or 2 out of 3 chances. okay? And if you wanted to do the experimental probability, you will get close to 2 out of 3. If you were to throw it, at least throw it 20 times, okay? Because if you only throw it like 5 times, you might have very the probability might look very off. It's not going to be 2 over 3, but you can get close enough if you do it many times. You're going to see that it is true that if you were to do the actual experiment itself, it gets close to 2 over 3 or 66.7% chances or probability. Shoot me a text or an email if you have questions, and good luck with your IXL practice.